For radical numbers, it says simplify each of the following. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And the square root of 25 is 5. So we have the product property, which means that, for example, when you have the square root of 200, of course, you can't take the square root of 200 and get a whole number. So you can split it up into two different numbers. So they split it up as 100 times 2, and then they split up the square root. So the square root of 100 times the square root of 2. Okay, now we can take the square root of 100 and get a whole number. So the square root of 100 is 10. So they put the 10 in the front. You don't have to put the square root anymore because you already got the square root of 100. It gave us 10. And then the 2, since we can't get the square root of 2 and get a whole number, it gives you this big long decimal, 1.7 dot dot dot, and it goes on forever. So instead of writing all of that down, you just leave it as the square root of 2. So I'm going to do some examples so it makes a little bit more sense. All right, so the first one, we have the square root of 20. So we need to keep these numbers in mind, which are your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You need to make sure you copy down these numbers. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. And that's where we're going to stop for today. So 20, we need to see which one of these perfect squares, these numbers that I just wrote down, can divide into 20. So between 1, 4, 9, 16. 16 is already too big to divide into 20. So out of those 4 numbers, which one will divide into 20? So we can see that 4 will divide into 20. So the square root of 20 is the exact same thing as the square root of, 4 times 5. Okay, now we can take the square root of 4 and get a whole number. I don't know why it's not changing colors. Oh well, equals. And so we're going to split it into two different square roots. One's going to be the square root of 4 times, the other one's going to be the square root of 5. Okay, now the square root of 4, like I said, you can take the square root of 4 and get a whole number. That gives us 2. But we cannot take the square root of 5 and get a whole number. That gives us a big, long decimal. So we're going to leave it as the square root of 5. So this gives us 2 and the square root of 5. Make sure you box or highlight your answer. So that would be our answer. All right. The next one, 63. So we see which one of these perfect squares up here divide into 63. And so the two numbers would be 9 times 7. So the square root of 63 is equal to the square root of 9 times 7. And we can split it up into two different square roots. We have the square root of 9 and the square root of 7. Now the square root of 9, we can get a whole number. The square root of 9 gives us 3. Oh crap. 3, sorry. And the square root of 7, we cannot take the square root of 7 and get a whole number. So we are going to leave it inside the square root. All right, let's move on to the next one, the square root of 80. So we look at all these numbers up here and see what number divides into 80. So we have 1, 4, 9, 16, 25, 36. And then I think 49 is going to be too big. Okay, so between all of these numbers, 4 and 16 will both divide into 80. So we have to pick one of those two numbers, and this is how you're going to pick. You have to go with the bigger number, and I'll show you why right now. So the square root of 80 is the same thing as the square root of 16 times 5. Okay, Now, had we have picked 4, 4 times 20 gives us, I'm going to write it off here to the side, 4 times 20 does give us 80 also, which is okay. But 20 has to be broken down again one more time. So 4 times 5 gives you 20, which ends up putting you with 3 square roots, which is a little bit more work. Is it impossible? No, but it is a little bit more work. So that's why I don't want you guys to have to do more work. You can just pick the bigger number, which is 16. Now the square root of 16 gives us 4. And then the 5, we cannot take the square root of 5 and get a whole number. And you could just leave it as 5. Okay, so you don't have to worry about all that work. We just need to do one simple step. Now, I did skip this step right here that I did on the previous problem. That's okay if you don't write that down, as long as you know which one stays in the square root and which one comes out. So because we took the square root of 16, that's why it comes out of the square root, because we already took the square root of 16. That gives us 4. The 5, we cannot take the square root of 5 and get a whole number, so that's why that one stays in the square root. Okay, now we have the square root of 3 times the square root of 12. Now 3 and 12 are imperfect squares. We can't take the square root of those numbers and get a whole number. So we're going to simplify this by multiplying. 3 times 12 gives you 36. So that's equal to the square root of 36. Now we know that the square root of 36 gives us a whole number, which is 6. All right, the next one, the square root of 6 times 24. So 6 times 24, I believe, let me make sure, is 144. Let's see. 6 times 24. Yes, it is 144. So this is the same thing as the square root of 144. And we know 144 is one of our perfect squares. That is 12. 12 times 12 gives you 144. All right, and then the next one, we have 42 times 3. So 42 times 3 is 126. Now, unfortunately, 126 is not a perfect square, but we can reduce that. So we look to see what numbers multiply to give us 126. Remember, one of those numbers has to be these numbers up here, okay? And so I believe 9 times 14 gives you 126. So we split it up as 9 times 14. And so we can take the square root of 9 and get a whole number. That is going to give us 3. And then we leave the square root, and then inside of the square root is 14. All right. Now we have the quotient property. So just like we're able to split up the multiplication, we can also split up the division. So you take the square root of the 25 and you take the square root of the 49. Okay, and you take them separately. So for this example, we have the square root of 64 over the square root of 25. So we can split it up into 2 different square roots. We have the square root of 8 over the square root of, I went a step ahead. The square root of 64 over the square root of 25. And we know the square root of 64 is 8, and the square root of 25 is 5. And then 8 over 5, we cannot reduce that fraction. It stays as 8 over 5. All right, the next one, we have the square root of 200. So we are going to split that into 2 numbers that multiply to give us 200. Okay, remember, one of them has to be a perfect square. So I know 100 times 2 gives me 200. Now 8, the same thing with 8. We know 4 times 2 gives us 8. So now we can take the square root of 100 and get a whole number. That gives us 10. So we write 10 outside of the square root, and we leave the 2 inside the square root because we can't take the square root of 2 and get a whole number. Then we have 4 here. We can take the square root of 4 and get a whole number. That gives us 2. But the 2 we cannot, so it's going to stay inside the square root. All right. 10 divided by 2, we can reduce that. 10 divided by 2 gives us 5. And then when we have a square root on top and a square root on bottom, they both cancel each other out because it's the exact same thing. So 5 would be our final answer. Next, we have the square root of 49 over the square root of 100. We can split it up. So we have the square root of a 7 over the square root. Why do I keep doing that? The square root of 49 over the square root of 100. And so the square root of 49 is 7 and the square root of 100 is 10. Now that we cannot reduce, the fraction is already all the way simplified, so we leave it as 7 over 10. All right, the next thing is rationalize. So somebody, I'm not sure exactly whose name it was, but he decided that it is not allowed to have a square root on the bottom. Why? I have no idea, but it's some weird rule that some mathematician made up. So to get rid of that square root on the bottom, what we have to do is we have to multiply the top and the bottom by that same square root. So because it's a square root of 5, we're going to multiply the top and the bottom by the square root of 5. So that means on the top we have 4 times the square root of 5. And on the bottom we have the square root of 5 times the square root of 5, which gives us the square root of 25. Now the square root of 25 gives us 5, so we are left with 4 and the square root of 5 on the top, and then we're left with a 5 on the bottom. All right, the next one, 1 over the square root of 6. So we're going to do the same thing. We need to get rid of the square root of 6 that's on the bottom. So we're going to multiply the top and the bottom by the square root of 6. So that's going to be 1 times the square root of 6 gives us the square root of 6. And then on the bottom, the square root of 6 times the square root of 6 gives us the square root of 36. Now we know the square root of 36 is 6. So it's going to be the square root of 6 over 6. And now the square root of 6 we cannot break down because the only thing that multiplies to give you 6 is 1 and 6 and 2 and 3. And none of these numbers are perfect squares, okay? Remember your perfect squares are 1, 4, 9, 16. All right, number 16. We have 3 in the square root of 2 over 8. So the 3 in the square root of 2 we cannot simplify. We're going to have to leave it as is over. But the square root of 8, we can break that down. The two numbers that give us 8 are 4 times 2, and 4 is a perfect square. So when we reduce this, we get 3 in the square root of 2 over. The square root of 4 gives you 2, so you leave it outside of the square root. And then the 2 here, we can't take the square root of 2 and get a whole number, so it stays in the square root. So on here, the square root of 2 and the square root of 2 cancel, and we're left with 3 over 2. And 3 over 2 is a fraction that we cannot simplify. It's in simplest form, so we leave it like that. Okay, now this whole thing that we did of getting rid of the square root on the bottom, it does have a special name. This is called rationalizing. So right here where it says, this is what it's called, rationalize. So it has a fancy name. To get rid of the square root on the bottom, it's called to rationalize. Adding and subtracting radicals. So it's kind of like x's. So for example, if we were to have 12x minus 4x, if you have 12 x's and you take away 4 x's, we're left with 8 x's. But in this case, we don't have x's. We have square root of 7s. So if you have 12 square root of 7 and you subtract 4 square root of 7, you're left with 8 and the square root of 7. Okay, so as long as just like you have x and y's, you can't combine an x with a y value. That's not possible. So as long as these two square roots are the same, you can add or subtract the numbers that are in the front. All right, number 18. So these fractions are not the same, but we can simplify them. So 75, we look for two numbers that multiply to give us 75, which is 25 times 3. And then we are going to subtract 27. The two numbers that multiply to give us 27 are 9 times 3. So we have the square root of 25. We can take the square root of 25 and get a whole number. That gives us 5. And then the 3 is going to stay in the square root because we cannot subtract it and get a whole number. Next, we can take the square root of 9 and get a whole number. That gives us 3. But we cannot take the square root of 3 and get a whole number, so that is going to stay in the square root. So now we have 5 and we take away 3. That is going to give us, whoops, it's going to give us 2. And then we have 2 and the square root of 3. Okay, you just subtract the coefficients. In the last example, 6 and the square root of 5 plus the square root of 45. So the square root of 5 we cannot simplify, but we can simplify the square root of 45. So we rewrite 6 and the square root of 5 plus the two numbers to give us 45 are 9 times 5. Okay, we're not done simplifying yet. So it's plus. Now we can take the square root of 9 and get a whole number. The square root of 9 gives us 3. And then we're left with the square root of 5. The 5 stays in the square root because we can't take the square root and get a whole number. So now we have 6 square root of 5s and 3 square root of 5s. So if you add 6 plus 3, that is going to give us a total of 9 square root of 5s. Okay. All right, I believe that was the last problem. So let's go ahead and take a look at something real quick on your assignment. Mr. Wyatt. All right, on your assignment, I just want you to do these problems here, 3, 4, and everything in these columns. So you're going to do just this side of the paper, okay? If you do have extra time at the end of the period, go ahead and try these ones for extra credit. So this would be extra credit, but you need to finish the regular credit ones first, and you need to turn it into the substitute at the end of the period. I don't know why it's not writing. These ones on this side are extra credit. Okay. Is it writing extra credit? All right, so we will not see you tomorrow. You will have another video tomorrow. It'll be on Pythagorean theorem. And then I'll let you know what to do on your assignment. Have a good day. Bye.